So last day, we talked about forces and how they might affect structures. Now, we talked about two categories of forces. They were internal forces and external forces. External forces are those that are separate from the structure and are acting from outside of the structure. Then there were also internal forces that are acting from within the structure because they are a part of the structure itself. Then we talked about how we might describe these forces. So we can describe forces in terms of its magnitude or the strength of it, in terms of its direction or which way it's being applied, and in terms of its location, where on the structure is the force being applied. So for today, we're going to continue talking about these forces that act on structures. So let's talk about loads. Um, Structures need to support a load. That's its basic purpose. Um, Other than that, all structures might have a different purpose, where some structures are meant to contain something or hold something inside it. Other structures might have a purpose, might serve the purpose of holding things up or supporting things off the ground, for example. Whereas other structures are just for aesthetics. They might just be there to look good, but it still has to be able to stand on its own. So, regardless of what the end purpose of a structure is, all structures are going to support some kind of a load. Now, what is a load? Load is the force that's exerted on a surface or body. The total load that a structure is able to support is the sum of the static load plus the dynamic load. We're going to talk more about those two things on the next slide, but this here is just a very basic formula showing you what the total load of a structure should support, okay? How to find the total load of a structure. So what is a static load? A static load is a constant force exerted on a structure and doesn't change unless the structure itself is modified. So for example, gravity is acting on the structure itself as is without having to, gravity is going to affect the structure regardless of whether or not the structure has something in it or not, okay? Gravity will just have its effect on the structure. And another example of a static load are the structural materials. What is the difference between having a roof that's made of metal versus a roof that's made of plastic? Okay, to go for a very extreme example there. Clearly, if you have a house that has a metal roof, the weight of that metal roof is going to be more significant than the weight of a plastic roof, for example. Okay. The dynamic load is the force that moves or changes while acting on the structure. So, for example, the weight and location of materials that you place on a structure. So, these tend to be materials or objects that are separate from the structure itself. A bookshelf, whether it's empty or has books on it, still is a bookshelf. Clearly, if there are books on the shelf, then those books are adding to the weight of the structure. Okay, so engineers and designers must think about what the structure is meant to hold when it is being built or designed so that they could plan accordingly. Now let's talk about internal forces. Internal forces are caused by one part of your body or the structure acting on another part of your body or the structure. There are four kinds of internal forces: compression, tension, shear, and torsion. I've provided a visual here to help you have an idea of what these four kinds of internal forces are. So compression is a force that squeezes together. So if you think about two opposite ends of a structure, think of something that might cause the structure itself to squeeze down. And that's what compression is. Tension is a force that stretches a structure apart. So think of a rubber band as a structure, and then when you pull it apart, okay, so I'm applying an external force, which could be my fingers that pull the rubber band apart, you can see what happens to the rubber band. But at some point, there is an internal force within the rubber band itself that creates that tension that stretches it apart. And if I apply a strong enough force, it's going to cause that Band-Aid to rip, okay? Or tear. Next, shear. Shear is a force that pushes in opposite directions. So it's slightly different from tension. Tension is almost the impression of pulling something apart, whereas a force is something that pushes the two ends of a structure in opposite directions. Okay? Finally, torsion. Torsion is a force that twists. So for those of you who are dancers, figure skaters, gymnasts, or somebody who takes part in an activity where twisting motion from your torso might be involved, then that's the torsion force. Okay, so that's the end of today's lesson. Please go back to classroom and complete the task that is assigned to you, and I will see you next day.